All right, thank you all very, very much. And thank you for the fascinating opening talk. I hope this plays into what you were saying and what you've heard. But I'll just jump right into this. So my name is Emily Gorcenski. I work for a company called ThoughtWorks. We are a global technology company where I serve as the what we're calling the data and AI service line lead for ThoughtWorks Europe. What that essentially means is I'm working with our clients solving their data problems, their AI problems, and trying to help build their platforms, build their products using data, and trying to get better value out of data. And one of the things that you might have heard of in the last couple of years is this idea that we've come up with that we call data mesh. And data mesh is sort of a new way of thinking about how to build data architectures. What's interesting about data mesh is that it sort of turns on its head the sort of traditional paradigms of how we work with data, and I'm going to get into that in a minute. But a lot of people come up to me all the time and they say, what actually is data mesh? Aren't we just doing data mesh? What's the difference between data mesh and data fabric? What's the point of doing data mesh? I'm going to try to explain some of that. But in order to explain some of that, I'm going to maybe take a little trip through history here. How many of you have heard of DevOps? That's most of you. Go ahead and raise your hand. Keep your hand up. Keep your hand up. How many of you have heard of SRE? Okay. How many of you are currently working in SRE or DevOps? How many of you are data engineers? Okay, that's like a completely disjoint subset. And the thing is, like, I don't know, maybe like 10, 15 years ago, we looked at how we were building software and we said, this doesn't work. We've been building software by compiling a bunch of artifacts after writing a bunch of code, and the devs are very happy because their like build process works, and then they have this nice like artifact that they take and they kind of hand it over to somebody in an ops team. They say, here you go, good luck with that. And then the ops team struggles to get it up and running and putting it into production, and then there's usually bugs, and then they have to go back to the dev team, and the dev team says, works on my machine, I don't know what you're talking about, and then they go back and forth, and it takes very many months, and then you get things like quarterly release cycles or biannual release cycles, and nobody's happy and everybody's grumpy. And this is how the internet used to be. Like, remember using the internet in 2005? Like, websites were down all the time. We said there's got to be a better way to do that, so we kind of came up with this DevOps mindset. You build it, you run it. We came up with things like containerization, where you have a portable sort of deployment environment for your application that you can then take to different runtime environments and have some consistency. And that was good. And nobody told the data people. Because in the data space, we've been doing things that look very, very much like what we were doing in the ops space a long time ago. People would collect data, and then they would just sort of shove it somewhere. They would throw it into a bucket. They would throw it into a stream, right? The sort of application stack today, we treat data as a hot potato. If you're building a microservice, your goal is to hold that data for as little time as possible and to maintain as little state as possible and just sort of take it in, and as soon as you're done with it, there it goes off into a Kafka stream, right? We don't want to deal with the data. Data is something that data engineers deal with. And data engineers kind of come from a pedigree of like database administrators who never let you touch their database, right? And what this was causing was a lot of sort of delay and pain and misery, really, in working with data. We were hearing all of the time, like data scientists, I'm a data scientist, right? Data scientists are constantly complaining. They'll tell anyone who will listen, oh, I spend so much of my day cleaning data. I spend 80% of my time cleaning data. I want to build cool models, but here I am working with building data pipelines and dealing with data quality. And analysts are always like, hey, can you pull me this data, right? Data engineers are always solving this like pull problem. And what we found working with our clients when we decided to kind of naively take our DevOps mindset into the data space was that these patterns of data architectures were leading to failures in bringing data value out of organizations. And these sort of 4 failure modes, I won't go into them all, were sort of repeated at organizations of every size in every industry. It didn't matter if you were like a 150-person scale-up or if you were a 150,000-person international enterprise. We kept seeing the same patterns over and over and over. Data engineers were doing very obscure work. It was all ad hoc. They were always firefighting. They were not innovating, and they were very expensive. You had stakeholders who didn't understand the data. You had data producers who didn't know what their data was being used for. This was all a very disconnected, very confusing environment, and it was costing people a lot of money. All of those promises of the big data era never came true. And so when we started diagnosing this, we looked back even further and we said, why is this the case? And we realized that even as technology changed, even as we moved from the data warehouse era to the data lake era, even as we moved from the data lake era to the cloud era, to the Lambda architectures, the Kappa architectures, streaming first, lakehouse, whatever, it was all the same thing. You had, if you go to somebody who's a data engineer and say, hey, draw your architecture for me, you're going to get the same thing. You're going to get a bunch of boxes on the left representing data sources, usually with systems with funny names. And you're going to have a bunch of use cases on the right, also systems probably with funny names. And then you're going to have some big monolithic thing in the middle that is some sort of data processing, data storage, computing environment architecture. And the problem is that your consumers and your producers are disconnected by this massive technology layer. And that massive technology layer also requires a lot of specialized skill set and knowledge to operate. And you have people that aren't talking to each other. And so we said, what if we change that? What if we actually break down that centralized paradigm? And what if we brought the sort of mentality of microservices into the data ecosystem? What would that look like? So we decided, of course, in order to do something like that, you can't just like decompose these massive monolithic systems, right? It's not like the easiest thing in the world to like try to decentralize a Teradata cluster. I've tried. So we decided to go with a principles-led approach, right? So we said, okay, the first principle is that we're going to go back to domain-driven design. This is an older idea. It worked very well for software. It's kind of fallen out of fashion, but now it's back again because it's cyclical. So we're going to say, we're going to have domain-driven data ownership. Data is generated in the domains. They should have ownership over the full life cycle of that data. The second is, we actually start needing to treat data as a product. That sort of hot potato mentality that I was describing earlier, we think of data as a byproduct of the system. We think of the system, the value of the system, in terms of its transactional value. I'm building a shopping cart service. The value of that shopping cart service is, that it does something over and over and over again at scale effectively. We think of the data as a byproduct, what that service emits that somebody else will get some value out of. Of course, in order to move decentralized, we need self-service data platform infrastructure, just like we have platforms like Kubernetes for containerized deployments. We need something like that for data. And then, of course, everyone says, well, if you decentralize, what are you going to do about data governance? So the answer was, well, you're going to start automating data governance, and you're going to make data governance a participatory function rather than a controlling and prescriptive function. And so this was the set of ideas that we brought into data mesh. And that kind of gave us some thoughts about how that sort of technical architecture should look. And so what we actually have here is sort of a network of the data mesh. The reason why it's called a mesh is because it's a network of domain-owned data products, right? You don't have data going into a centralized architecture and then coming out of a centralized architecture. You have data products connecting directly to each other, owned by domains, exchanging their data directly to each other, but supported by a data infrastructure platform that is domain agnostic. That means your storage layer, your computing layer, all of that good stuff is going to sit down in that sort of domain agnostic platform layer. And this idea is, I guess it's not really that radical if you have worked in microservices, but for data, it's actually very difficult to implement some of this. The technology that we have is not always there to be able to do this. And we're not actually just also not used to working in this way. Data engineers are very difficult to find on the market, and it seems kind of impossible that we would be able to put data engineers into each domain. So the good news is we've figured out a lot of these problems, and the even better news is that the technology is changing to make this a lot easier. And so what have we seen so far with data mesh? Well, we've been doing this now for 5 years, and almost everyone that I talk to, they're really wowed by these promises that data mesh with its decentralized architecture is going to make the data access problem easier. They're hopeful that it might make the data management problem easier as well. These are the two biggest pains that most companies have. But in the data space, we often have this mindset of the next problem is the biggest problem, right? Like you kind of have this mentality like, if only I had a data catalog, all of my problems would be solved. If only I had, better data quality, all of my problems would be solved. And that's not always the truth, right? We kind of focus on these data consumer use cases. What we have yet to sort of try to crack is what is in it with a data mesh architecture for the people who are producing the data. So what is it that we can still learn from the data mesh deployments, right? This is one of the questions that clients are starting to ask now. They're saying, why, what's in it for me? Why should I, as a data producing team, commit to this much more complex architecture? Why should I, as a data producer, commit to owning the data lifecycle? Why should I commit to owning the data quality? It was so much easier when I could just throw the data over a wall and let somebody else deal with it. And of course, there's other questions about this, like what do we do with external data, right? How do we manage data that's coming in from out of the organization, or how do we manage data that's supposed to flow out of the organization? This question is becoming more and more pressing as we start looking at the adoption of the EU Data Act. I was at an event a couple of weeks ago, listened into a panel, experts on the act. Apparently, they're saying that it's about 20 months from the implementation of this act, and this will require people who are collecting data with devices to be able to share that data, to make that data available to their users. And so the challenge of moving data between organizations is going to get a lot more pressing because it's going to be mandated by law. But the other thing about working with data is when you start looking at this sort of consumer use case with data, you start to realize that it's not really a technology problem at all. When you work with data, you actually realize that you're dealing with this sort of the remnants, the background radiation of organizational structures. If you look really closely at data, you can even see the moment that two teams stop talking to each other because the schemas start to drift or the data quality starts to drift. So I like to joke that it's sort of 3 parts archaeology, trying to unearth the past, 2 parts anthropology, trying to understand the culture and how people communicate, and then finally 1 part technology. So that's a bit about data mesh. But I am here to talk about, actually, decisions. I'm here to talk about products. So if we look at a modern business, modern Fortune 500 company, there was some research that was done by McKinsey a few years ago. They did some back-of-the-envelope calculations, and they found that the average Fortune 500 company makes about 400 million decisions in a day. Now, most of those decisions are fairly irrelevant. Things like, where do we take the team out to lunch? And do I need to restock the paper in the printer room? But some of those decisions are very important. Things like, should I expand into a new market? Or where do I find the talent? How do I upskill my workforce for generative AI? And these decisions are always demanding data for us to make them. We never have enough data to make these critical decisions. And so if we think about a business as just a massive decision engine, data is the fuel for that engine, right? We need to rethink the value of data throughout the organization. Moreover, that data that we collect has a shelf life. There's sort of this saying, like maybe you've heard it before, like data is the new gold or data is the new oil. I hate this metaphor. Data is the new oil only in the sense that it's liable to leak and make a huge expensive mess for you. Data is actually more like the new milk. It goes bad if you let it sit around. It becomes worthless if you don't act on it. We need to be able to use that data to make decisions, but those decisions need to be timely. They need to be effective. They need to be located within a point of time relevant to when that data is generated. If you're sitting on data, right, for a year, 2 years, 10 years, before you use it to make a decision, you could have made that decision 1 year, 2 year, 10 years ago, right? Think of all of the money that you've left on the table by not acting on that data. And so what we actually want to do is we want to be able to use data to make these decisions better. We want to make higher quality decisions based on a more complete picture of the information that we have. We want to be able to make those decisions faster. We don't want to have long cycle times where we are thinking and rethinking and overthinking the decisions that we make. And we need to be able to make decisions at scale. We need to be able to automate a lot of those 400 million decisions. We need to be able to have traceability in those decisions, to look at the quality, to evaluate whether we're making the right ones given the information that we have. The other interesting thing about data is that it is a multiple scales value add. That hot potato sort of behavior, like get rid of the data as fast as you can, that kind of ignores the actual value that we have with data. If we think of something like transaction data for e-commerce, right? You can have that data adds additional value to you at multiple scales throughout your operational life cycle. If we think of something like the sort of exploitation of user preferences, a recommendation engine when they go to check out, or improving product search, we can sort of think about how we might affect user behavior in a mutually beneficial way. But we also might incorporate that data over a longer time scale and say, how can we use this to make better marketing campaign decisions or better product decisions or get strategically relevant insights in order to reduce user churn? We then might even then take that data and integrate it into a larger scale and say, how can we understand industry trends? How can we shape partner relations? How can we use it to track our SLAs between our suppliers, for example? So that each point of data has a ripple effect that exists and amplifies over time. It's reusable at multiple scales, and those scales can be measured by both time and volume. My background, so I mentioned I'm a data scientist. Actually, I studied aeronautical engineering. I built real-time control systems for aircraft. It's amazing how much data a single aircraft generates. This was said publicly at an event recently, so I can repeat it. And I think that an Airbus, I think it was the A320, generates some 20+ thousand sensor parameters during as it flies, right? That's a massive amount of data. And this data exists at timescales from milliseconds to years. That data is useful, of course, to control the aircraft, to make sure it's flying safely and efficiently. It's also used to do things like predict the maintenance state of the engines. Do we need to take down the engine to repair it, or can we keep flying? It's also used, of course, to help design better fleets, design better products, design better, more efficient, more powerful airframes or engines, right? This data continues to be useful over and over and over and over. The problem is that this is a really difficult problem to solve. It's a nearly impossible problem to solve mathematically from the engineering point of view, but also from a technical point of view. How do you integrate millisecond scale data across a time span of years or even decades, right? So being able to make use of this data requires a technical approach and a technical architecture that allows us to do this at scale. So how then do we actually take this data to make decisions out of it? Well, we actually do know how to use data to make decisions. We have this sort of workflow, right? We have some data, we analyze it, we use it to formulate a hypothesis. Have any of you worked with like hypothesis-driven development? This might look familiar. We design an experiment based on that hypothesis to test that hypothesis, and we use that to collect more data. We evaluate those results, and then we analyze that data. And so this is a loop. This is actually just sort of the scientific method. And if we look at all of the data that we have in the organization, the reason I say that it's sort of like archaeology or anthropology is because data only exists because a human decided to measure something, and that measuring it and storing it was important. We know how to do this. We do this all the time. We do this for drug development. We do this for building better cars. We do this for understanding how to fly people around the world better, how to ship things to people's homes better. This is something that is very innate, but we often don't think about bringing this into our product development lifecycle in such a formalized way. And so what I actually like to think of is that data products are emerging from hypotheses, right? So when we're designing a product, we don't actually need to wait for a bunch of data. We can actually start with the hypothesis. We can start by simulating what our product might do. We can start to simulate the experience. We can start to model the behaviors that we want to see. And that will help us identify the signals that we need to collect, the inflection points that we need to be listening for. We actually want to think about what data we are collecting. Too often I see that companies are collecting a massive amount of data. They have terabytes and terabytes and even larger in their data warehouses, in their data lakes, but all of that data is useless because people just decided in the big data era to collect and hold data because we all said that data was the new gold. What we're finding is that teams are spending years sometimes collecting the wrong data. And so when it is finally time to go and say, well, hey, I've collected all this data, can't you like hit it with like a big machine learning hammer? And then like a bunch of money will come out. But it turns out that they were listening to the wrong things. They were looking at the wrong signals. They weren't collecting the right stuff. Or that we don't know what the context of that was anymore. And so what we actually want to do is we want to refactor our product development lifecycle for shorter feedback cycles and parallel experimentation. We want to think about an idea, turn it into a product, get ideas from that product, and turn it into a new product over and over and over. So what does data mesh have to do with this? Well, the first of these problems, as I mentioned, is that producers and consumers, the people who are generating the data and the people who are using the data, are often not talking to each other. One of the things that means, or one of the effects of that, I should say, is that producing teams are not using their own data. They actually don't know how their data is being used to make decisions in the business. They don't actually know the full impact of what they're building. So the data mesh is a way of giving that team the tools to work with their data so that they can actually look at the full life cycle, they can manage the full life cycle, and they can design products for better, long-term, repeatable value beyond the initial design. Second is it allows us to build for the data that we need and not the data that we have. It's a more compartmentalized way of being able to work with data, so we're able to fine-tune how we're actually collecting those signals, working with that data from the beginning. We can integrate that into our design process. When we do our product design, when we do our sort of conceptualization, we should also be conceiving of the data and how we're going to be using it at the same time. And it allows us to do things that are small before doing things that are large. Too often I hear people saying, I would love to be able to work with this data. I'd love to be able to do machine learning, but I don't have enough. I need to get more data. I need to buy data. I need to combine, fuse data. No, you actually don't. We can actually start doing machine learning and AI. Even with small data, we can start right away. So it allows us to be a little bit more lean and agile with that. And so what we're actually doing with data mesh, what we're actually achieving is that data mesh isn't just a way of getting access to data throughout the organization. It's a way to get access to decision making throughout the organization. It's a way to access knowledge. And if you look at the actual technical implementation of data mesh, which is a specification-led way of doing it, just like when you build a Docker file or a Docker container, you have like a Docker file, you declare what you need in it, where the code is, and what sort of runtime it's going to be in. We specify our data products in much the same way. What that gives us is it lifts our knowledge graph up automatically, so we're able to see that lineage and that flow of information in a very natural way. So data mesh allows us to get access to this information. So how do we do this? Well, first, as I've mentioned, product teams need to actually become more fluent at using their own data. They need to actually not simply wait for the clickstream analytics. They need to not just wait for the data analytics team to give them some results. They actually need to be forward thinking and actually integrate data into their workflows and into what they're doing. We're too often used to pushing data and pushing information into a platform without thinking about how we get it back. So the first thing is enable product teams to start working with their own data. And the way that to do that is to make sure you have that self-service architecture for them to have access to that data. Second, we want to standardize around data quality. You probably have heard of FAIR data, the findable, accessible, interoperable, and reusable. We have because we're ThoughtWorks and we love to reinvent things sometimes, we have this sort of 6 principles that are kind of like FAIR, but a little bit broader. Discoverability, of course, addressability, trustworthiness, the self-describability, right? The semantic context needs to be there with the data, otherwise you will never be able to use it at the longer term scales. Security, of course, is important, and that sort of interoperability, the standards-based approach to working with the data. And so we want to kind of come up with that standardized format. We want to be able to build that sort of metaphor of the containerized deployment for a data product. Of course, this gives, as I already mentioned, it gives us the knowledge graph, but it also gives us the ability to deal with data versioning much more easily. Because the data mesh, the sort of data product architecture, allows us to create different endpoints for accessing that data. You can have those parallel flows. You solve a lot of your problems in that way. We also want to think about the data product user experience. We're talking about product experiences and user experiences all of the time. What is the product flow? What is the user's flow through the product? Let's actually think about the user's flow with the data. We often don't think about our internal users, our analysts, our data engineers, our reporting team. We don't think of them as users too often. We do need to think about them as users. We need to have that platform as a product mentality when we're thinking about data. And so we can think about what types of usage patterns might this data product fit? How often will it be used? How fresh does the data need to be? How many people are using it? Is it 100 people? Is it 10 people? When are they going to be using it? Do they need to access it 24/7? Do you have an analytics team all around the world, or are you using this data to feed a machine learning algorithm that might be running in real time? Or do you need to have, just a really curated report that's available in the morning so that your sales team can make its decisions? And then, of course, we want to be able to own our own data pipelines, right? One of the challenges that we have with data products, this is a very technical diagram. I don't know why I put this one in there instead of one of the other ones. One of the challenges that we have with data engineering teams is that, they don't actually understand the data, but nobody else has the ability to build data pipelines, and that seems like a mismatch of prioritization. We actually want to be able to make it easy to build data pipelines. Beforehand, we used to say, oh, we can't have our developers doing operations because the deployment process is so complex. We don't want them to manage that. So what did we do? We made it easier for them to build their own pipelines. Nowadays, you have, working with your own CI/CD pipeline is sort of second nature for a lot of teams. We can do that with data pipelines as well. And so what we have here, and this is, again, a very complex diagram, this little hexagon is a data product. This is its boundary. And rather than putting the ETL process in a centralized platform, we are allowing each data product to own its own ETL process. It pulls data in from the input ports, and it pushes it out through the output ports. I've mentioned the sort of standardized approach. We want to be able to define data products as code. We have a specification format. Here it's JSON. I prefer YAML, but we can actually define our data product in a very simple and straightforward manner once you have a platform that is expecting that file format and knows what to do with it. So I define a data product here. I've hidden a lot of the information, but I define my input ports. My input ports are, of course, other data products. I define the schema based on the schemas that they register with a catalog. I define my output ports. What am I producing that has value with this data? And then I define the processes that I need to apply in order to transform it. I take this, I have a one-click deployment of this specification, and the platform sets up all of the infrastructure that I need in order to work with my data product. That's really great, and if you can do that so simply in your product teams, then your product teams can also have access to that data in order to do smart things with it. And of course, I mentioned the knowledge graph that you get for free. So this is what happens when you start building and deploying data products as they connect to each other. If you look at the blue things, those are ports, so input ports and output ports. And you have this, what we call here an employee data product, employee DP. You can see it reads from 2 event streams and produces an employee details report. We then have another data product that reads from that employee details report to do something else with it. This is, everyone's talking about how do I do data lineage, how do I do data lineage? We create this essentially for free from the specifications. There's no need for advanced technology. So let's bring it home. I want to think about changing the mindset of data overall. This whole idea of data producers and data consumers still creates that sort of left to right workflow that I was saying was so problematic at the beginning of this talk. I actually want to get away from that mindset. I want to think about products that drive experimentation, right? Products that produce a lot of data that allow us to experiment with our business and experiment with what we are doing, experiment with understanding our users, our ecosystem, our environment, the economy, whatever it is. And then products that exploit those conclusions. I want to move from simply a data-led way of thinking or a product-led way of thinking to an experimentation-led way of thinking. I want to think about every product simply as the best experiment that we have produced yet. If you think about this, anytime you're building software and you're trying to learn from your users' behavior and you learn from how those users are using that software, you should be moving into a continuous improvement sort of mindset. But how do you continuously improve if you're not testing and validating hypotheses? How do you know if you're doing the best thing if you are not testing to see if you are doing the best thing, right? So instead of thinking of a product as a finished and finalized state, think of it as the best version of the experiment that you have created yet. This is not only true for software products, but you can think of, the iPhone that I have is simply an experiment, and that's why Apple is releasing new ones all of the time, right? They're continuously learning from their customers' behaviors and improving the technology, improving the product experience, and improving the sort of way that we work with these devices and how we integrate them into our lives. This is true whether you're building a software product, a physical product, a financial product, an abstract whatever, a service product. We actually want to be able to continuously improve. And the only way that we can do that is if we actually optimize for decision making. So when you get that information about when a product is doing better, you need to be able to act on it. It's like 2023 and everyone's talking about Gen AI, so I had to throw this slide in, right? Generative AI has actually been around for a while, and one of the things that people are doing is using generative AI to bootstrap the creation process. There's a website called thissneakerdoesnotexist.com. It's somebody that's been using generative AI to come up with new designs of sneakers that don't exist. And there are actually sneaker companies that are using this sort of workflow to come up with new designs. They're looking at existing designs in the market, they're looking at different trends, they're integrating new ideas, and they're using generative AI not to come up with the design of the sneaker, but to come up with the prototyping, to make that process of conceiving what they want to do a lot faster. Of course, then they hand it over to their actual designers where they can actually bring that sort of design into reality. So you can actually use generative AI and computational creativity to bootstrap a lot of that process, and of course, if you're going to do that, you're going to need to capture this data, you're going to need to act on this data, you're going to need to record this data, and this needs to be part of your product teams as well. So they need to have access to the tools that can do this. So what does these sort of disparate concepts, how do they all come together? So the way I like to think of it is that data mesh is sort of the backbone of your decision factory, right? So if you accept the hypothesis or the premise that businesses are just making decisions over and over and over at scale. And if you accept the premise that the product development process is nothing more than a sequence of data-informed decisions, then what we can actually think about is that data mesh is actually going to be the backbone of this sort of decision factory. It allows us to connect decisions between different parts of our business, and it reduces the friction of sharing that data that you need in order to make the decisions that you need to make. It basically facilitates that creation process. So I'll wrap up there. I should maybe have 1 minute for questions. I don't know. Yes, no? But happy to chat afterwards. Thank you very much.